Hello friends, I am Dr.Chishty and I am teaching to BSc third year physics. My topic is wave particle duality, and in this topic today we are going to study about the total energy of the electron in an orbit of an atom using the Heisenberg's principle. So we studied the Heisenberg's principle, and it states that the product of uncertainty in the momentum, and in the distance or in the position, not distance, in the position, should be greater than or equal to h cross upon 2. So today we'll use this formula of the uncertainty principle, and the uncertainty in the position of the electron is about 10 to power minus 10 meter. Why it is 10 to power minus 10 meter? Because the atomic radius is about 10 to power minus 10 meter. Possibility of electron to be found in this area only of the order of 10 to power minus 10 meter radius. Therefore, I am substituting here for the position as 10 to power minus 10, and I will calculate the value of delta P as greater than or equal to h upon 4 pi into 10 to power minus 10, because h cross is h upon 2 pi and the position is 10 to power minus 10. So I will substitute here the value of h as 6.63 10 to power minus 34. H is a Planck's constant. 4 as it is, 3.14, value of pi 10 to power minus 10, and it is calculated as 5.2 into 10 to power minus 25 kg meter per second, which is called as the momentum, means uncertainty in the momentum, as 5.2 into 10 to power minus 25. And we have to calculate the total energy of the electron. We have to calculate the total energy of the electron in an orbit, in an atomic orbit. Therefore, the total energy is the sum of the kinetic energy plus potential energy. Kinetic energy is given by the formula P square upon 2m. Why? Because we know that the kinetic energy is half mv square. Multiply by m and divide by m, you will get m square v square by m. This mv whole square is p square. Mv means momentum. So formula for kinetic energy is p square upon 2m. So I have calculated the uncertainty in the momentum as 5.2 into 10 to power minus 25 whole square. Mass of the electron 9.1 10 to power minus 31 kg. These are calculated as 1.5 10 to power minus 19 joule. Now convert this joule into the electron volt. Divide the answer by 1.6 10 to power minus 19. Comes out to be 1 electron volt. So now we have calculated the kinetic energy, approximately 1 electron volt, 1.6, 1.5 on 1.6, nearly about 0.95, 0.96. So it is nearly 1 electron volt approximately. Now the potential energy. Potential energy can be calculated using the formula of the electric potential into the charge, value of the charge. Electric potential is given by Ze upon 4 pi epsilon 0 r, where Z is the atomic number, E is the charge, and pi is constant, that is 3.14, epsilon 0 is 8.85 10 to power minus 12, r is the distance. So you will get the formula potential energy is equal to minus Ze square upon 4 pi epsilon 0 r. Now I will substitute here the values of E as 1.6 10 to power minus 19 coulomb charge, then value of pi, value of epsilon 0, and the distance is 10 to power minus 10 meter atomic distance, and I will get the answer as minus 14.4 electron volt. Here you will get the answer in joule. Divide that answer by 1.6 10 to power minus 19. I am keeping Z as it is. Now I got the potential energy, I know the kinetic energy. Find the total energy as kinetic energy plus potential energy. So kinetic energy is 1 in electron volt minus 14.4 into Z. For hydrogen atom, Z is equal to 1. So I will substitute here 1 minus 14.4 comes out to be minus 13.4 electron volt. This answer is in perfect agreement with the theoretical values of the total energy of the electron in the first orbit, which comes out to be minus 13.6 electron volt for the hydrogen atom. As we have calculated using the Bohr's postulate, Bohr's theory as minus 13.6 electron volt for hydrogen atom. Similarly, we can calculate for helium atom. Put here Z equal to 2. So 1 minus 14.24 into 2 comes out to be 1 minus 27.8 electron volt for helium atom, total energy of the electron. So using the Heisenberg's principle, we have calculated the total energy of the electron in an atom. Thank you.